Your last conversion factor is mole ratio. It is converting from 1 mole to another mole. So the first 3 conversion factors that we used, you always had the same element or compound before and after. When we use mole ratio, we are going from one element or compound to a different element or compound. So if you see here, we are going from A to B. A is an element and compound, B is a different element and compound. When we use the mole ratio, the units are both moles. The units are the same. We determine the number in front by the coefficient of the balance equation. We need to always write a correct balance equation. Lead-2 nitrate is ionic compound because lead is a metal. So we need to find the symbol and charge. Symbol is Pb. Charge is given to you in the parentheses because this is a transition metal. Nitrate is NO3. Charge is 1 crisscross. So that's Pb. Parentheses NO3, parentheses 2 because there's more than one lead. Potassium iodide is also an ionic compound because potassium is a metal. Charge of potassium K1. Iodide is iodine 1. Crisscross, so is Ki. So lead-2 nitrate is a compound. Potassium iodide is a compound. So this is going to be a double replacement reaction. So we know that the metal is going to replace the metal. So lead's new partner is going to be iodine. Charge of lead is 2. Iodine is 1. So we crisscross. So this becomes PbI2. K's new partner is nitrate. Charge of potassium is 1. Nitrate NO3 is 1 crisscross, so it's KNO3. Next, we need to balance. The leads are balanced. We have 1 on each side. The nitrates, we have 2 because there's the parentheses. So I need a 2 in front of KNO3. That makes it 2 potassium on the right side. So I need to put 2 in front of Ki. So there's 2K, 2 I's, and there are 2 I's on the right side. So this is the correct balance equation. So the next step, it tells you to calculate the moles of lead-2 iodide that can be produced from 5 moles of potassium iodide. First thing we're going to do is we're going to start with what's given, which is 5 moles of potassium iodide, Ki. We're going from potassium iodide to lead iodide. So that means we need to go from one element or compound to a different element or compound. When we change elements or compound, we must always go through mole ratio. Mole ratio tells you that mole of A will equal to mole of B. In this case, it's going to be the moles of Ki is going to equal to the moles of potassium iodide, which is PbI2. So where do we get those numbers? Remember, the numbers are the coefficient of the balanced equation. So the number in front of Ki is 2. So this is going to be 2 moles of Ki. The number in front of PbI2 is 1. So this is 1. So this is equivalent. 2 moles of Ki equals to 1 mole of PbI2. So we're going to continue on. So moles of Ki, moles of Ki. We're going to moles of PbI2. So the number in front of moles of PbI2 is 1. The number in front of moles of Ki is 2. So 5.00 times 1 divided by 2 is 2.5. Now I need to do sig figs. Conversion factors don't count. I have 3 in the front, decimal significant digits. So these are not trailing 0. Those zeros are significant. So I need 3 in my answer. I have 2, so I need to add a 0. Moles of PbI2. Remember, the only time you could change one element to a different element or compound is when it's the mole ratio. The units have to be the same. Again, we need to write a correct balance equation, which we already did. And we're going to start with what's given. What's given is 3.750 grams of lead nitrate. What are we looking for? We're looking for potassium iodide. Since we are going from one element compound to a different element or compound, we must go to moles. So that means we have to convert grams to moles. So we're going to do that. Diagonal units, grams of lead nitrate. This has to be grams of lead nitrate. Diagonal units have to be the same. And this is going to equal to 1 mole of lead nitrate. So we're going to use molar mass, which states that 1 mole of lead nitrate is equal to its mass in grams of lead nitrate. And we get the molar mass using the periodic table. So lead nitrate has 1 lead, which is 207.20 grams. It has 2 nitrogens, which is 14.01 gram. And it has 6 oxygens, which is 16.00 grams. If I add all this up together, you should get 331.22 grams of lead nitrate. So the number in front of grams of lead nitrate, because these are equal to each other, is 331.22 grams, and diagonal units cancel out. So if I stop here, I'm at moles of lead nitrate, and I don't want that. I want the moles of potassium iodide. So again, we do diagonal unit, moles of lead nitrate. This has to be moles of lead nitrate for it to cancel out. And we need to go to moles of potassium iodide. We can only change compounds or elements if it's a mole ratio. So since it's a mole ratio, we know that the moles of Ki has to equal to the moles of lead nitrate. And where do we get these numbers? It is the coefficient of the balanced equation. The number in front of Ki is 2, so this is 2. The number in front of lead nitrate is 1, so this is 1. So lead nitrate gets 1, moles of Ki get 2. The diagonal units cancel out, so now we multiply 3.75 times 1 times 2 divided by 331.22. This equals 0.01133217. Now I need to do sig figs. Conversion factors don't count. Conversion factors don't count. There are 4 sig figs in the beginning because there's a decimal significant digit in front. So my answer needs 4. I start at the left, go to the first non-zero digit, which is the 1. I count 4, 1, 2, 3, 4. I look to the right. It is less than 5, so the 2 stays. So this becomes 0.01132 moles of Ki. In the next problem, we're going to calculate the volume of potassium nitrate from 97.03 moles of lead 2 nitrate. So the first thing we're going to do is start with what's given, which is 97.03 moles of lead nitrate. Again, if you don't know where to start with what's given. And diagonal units have to cancel out, so this has to be moles of lead nitrate. We're looking for the volume of potassium nitrate. So it is a different element and compound. The only way we could change element and compound is go through mole ratio. Mole ratio states that the mole of lead nitrate equals the mole of potassium iodide. Where do we get the numbers? The balance coefficient. So the number in front of lead nitrate is 1. The number in front of potassium iodide is 2. So we're going to go from 1 mole to 2 moles of Ki. So diagonal units cancel out. But if we stop here, we have moles of Ki. We do not want moles of Ki. We don't want the moles of Ki. We want the volume. Volume is in units of liters. So I continue on. Moles of Ki, diagonals have to be the same. Moles of Ki. We could go from moles of Ki to volume of Ki. This is called molar volume. Molar volume states what? 1 mole of Ki is equal to 22.4 liters of Ki at STP. So the number in front of liters is 22.4. The number in front of moles is 1. Diagonal units cancel out. So now I multiply 97.03 times 2 times 22.4 divided by 1. If you do that, you should get approximately 46.9. We need to go back and do sig figs. These are conversion factors. So I look at the original number there are 4 significant digits. The 0 is significant because it's surrounded by significant digits, so I need 4 in my answer. 1, 2, 3, 4. I look 1 to the right. Since it's greater than 5, I round up, so this is 4,347 liters of Ki. Pause the video, solve this problem, and then check your answer. So in this problem, we have the combustion of propane. So first thing we need to do is write a correct balance equation. Since it's a combustion reaction, we know that C3H8, which is a hydrocarbon, reacts with oxygen gas O2 to produce CO2 plus H2O. Next, we need to balance. There are 3 carbons, so we need to put a 3 in front of CO2. The carbons are balanced. There are 8 hydrogens. We need to put 4 in front of hydrogen to make it 8 hydrogens. Now we count the oxygen. This is 3 times 2, which is 6. 4 times 1, which is 4, separated by a plus, so there's 10 total on the right side, so I need 10 on the left side, so I need a 5 in front, so it's 502. So if 5 grams of propane burns completely, what is the volume of carbon dioxide? So we need to go from propane to carbon dioxide. Since we are going from one element compound to a different element compound, we need to do mole ratio. So that means we need to start with what's given, which is 5 grams propane, because that's what was given, C3H8. Diagonals have to match, so this has to be grams, C3H8. Since it's gram, we know this step is molar mass. So we know it's going to go to 1 mole of C3H8. To find the mass of propane, we know there are 3 carbons, 12.01 grams. We know there's 8 hydrogen, 1.01 grams. If you do your math correctly, this is 44.11 grams per mole. So 1 mole of C3H8 is 44.11 grams. Diagonal units cancel out. If I stop here, I'm at moles of C3H8. So I go again. Diagonals have to be the same. This has to be moles of C3H8. Since I am going to different element and compound, from propane to carbon dioxide, I know I need to do mole ratio because this is the only time I could change my element or compound. The numbers in front of mole ratio is the coefficient. The number in front of CO2 is 3. The number in front of propane is 1. Diagonals cancel out. Next, moles of CO2. Moles of CO2. We're going to volume. So this is going to be liters of CO2. Molar volume tells you that 1 mole is equal to 22.4 liters. So if I cancel out all the diagonal units, I end up with liters of CO2, and that is what I'm looking for. So 5 times 3 times 22.4 divided by 44.11 times 1 times 1, you get 7.6173. Now I need to do sig figs. These are all conversion factors, so they don't count. There are 3 at the beginning. There's a decimal significant digit. These zeros are significant, so there's 3. 1, 2, 3. I look 1 to the right. This is 7.62 units of liter of CO2. In the next problem, we have 75.0 liters of steam, and we need to find the mass of propane. So again, we're going to start with what's given, which is 75.0 liters of steam. Steam is H2O. Liters of steam. Liters of steam. We know since it's liter and it's at STP, this is molar volume. We know that 1 mole of H2O has to equal to 22.4 liters of H2O. Diagonal units cancel out. Again, since this is moles of H2O, this has to be moles of H2O. Here, we are at mole ratio because this is the only time we could convert from moles, convert from one element compound to a different element compound. So this is going to be moles of H2O to moles of propane. The coefficient in front of water is 4. The coefficient in front of propane is 1. So that means this is 1 to 4. Diagonal units cancel out. If I stop here, I am at moles of C3H8. So I need to go again. So moles of C3H8, moles of C3H8. We're looking for mass. So we're going to do molar mass, which is grams of C3H8. This is equal to 1 mole. And we are looking for the mass of C3H8, which we found up here as 44.11. So I multiply 75 times 1 times 1 times 44.11 divided by 22.4 times 4 times 1. You should get approximately 36.922. Now I need to go back and do sig figs. Conversion factor, conversion factor, conversion factor. So I have 3 at the beginning. That 0 is significant because there's a decimal and a significant digit in front. So I need 3 in the final answer. 1, 2, 3. I look 1 to the right. Since it's less than 5, it stays grams of C3H8. So let's look at this last problem. Again, we are using the same balance equation. I'm just going to recopy it. So here we start with 34.2 grams of propane, and we're looking for the moles of steam. So we're going to start with what's given again. 34.2 grams of propane, C3H8. Diagonal units have to cancel out, so grams of C3H8. The only conversion with grams is molar mass, which tells you 1 mole of C3H8 is equal to its mass, which we calculated above as 44.11 gram. Grams of C3H8 cancel out. So diagonal units need to cancel out, so this has to be moles of C3H8. And since we're going from propane to steam, we're going to do mole ratio because this is the only time we could change one element compound to a different element in compound. The numbers in front of the moles are from the coefficient of the balance equation. Water has 4, so there's 4 moles of water to 1 mole of propane. So if we stop here, we are at moles of steam, and that is what we're looking for, moles of steam. Once you cancel out all the units that you are looking for should come out. If you have other units and they have not canceled out, you did not solve correctly. So 34 times 2 times 1 times 4 divided by 44 is equal to 3.1013. So now I need to do sig figs. Conversion factor doesn't count. Conversion factor do not count. There are 3 sig figs. So 1, 2, 3. I look 1 to the right. The 0 stays. So 3.10 moles of water. So general rule for stoichiometry, you must write a correct balance equation. The coefficient of the equations are used for mole ratio. You always start with what is given. So there will be a number given, so you start with that number. Always write the element or compound and the unit. This will help you keep track of what you are looking for and what is being canceled out. Remember, diagonal units always cancel out. So if you are stuck, start with diagonal units. So if it's gram, then you know it's molar mass. If it's liters, you know it's molar volume. If it's the other molecules, atoms, ions, particles, then you know it's Avogadro. The remaining unit is what you are looking for. What that means is after you cancel everything out, the leftover unit should match what you are looking for. If it does not match, you did something wrong or the units did not cancel out. So redo the problem. Pause the video, solve the following, and then check your answer. In this problem, the equation is provided for you, but you need to make sure if the equation is balanced. So we're going to count to see if the equation is balanced. So there is 6 carbon, 12 hydrogen, 6 oxygen. On the right side, we have 3 carbons. There's 2 from C2H5OH, the alcohol. CO2 provides 1 carbon. So there are 4. There is 6 hydrogens. And then there's 3 oxygens, 1 from the alcohol and then 2 from the CO2. So we're going to balance the hydrogens first. So there's 12. So I need a 2 here. That makes it 12. So now I have 4 carbons in this problem. So I'm going to put 2 here. 4 plus 2 is now 6. So my carbons and hydrogens are balanced. Now I need to look at my oxygen. I have 2 oxygen from ethanol or the alcohol plus 4, which is 6. So my coefficients are 1, 2, 2. So here we're going to again start with what's given, which is 500 grams of glucose. And we need to find the mass of ethanol. Since we are changing elements and compounds, we need to go through mole ratio. So we have grams of glucose. Diagonals have to be grams of glucose. This is molar mass, which tells you 1 mole of glucose is equal to its mass. Glucose is C. There's 6 of them, so that's 12.01. There are 12 hydrogens, which is 1.01 grams multiplied. And there's 6 oxygen, which is 16.00 grams. If I do all my math correctly, I should get 180.18 grams. The grams of glucose cancel out. If I stop here, I'm at moles of glucose, and I don't want moles, I want ethanol. So I need to go again. Moles of glucose, moles of glucose. Here we could go from glucose to ethanol because we are at the mole ratio. This is the only time we could change element or compound. The numbers in front of the moles is the coefficient of the balance equation. Ethanol, there is 2. So I'm going to have 2. The moles in front of glucose is 1, so I'm going to have 1. If I stop here, I'm at moles of ethanol. I don't want moles of ethanol. I want mass, so I need to go one more time. Moles of ethanol, moles of ethanol. There's 1 mole, and I need to find its grams of ethanol. So ethanol, there are 2 carbons, 2 times 12.01 grams. There's 6 hydrogens. The reason there's 6, there's 5 here and a hydrogen at the end. This is going to be 6 times 1.01 gram. And then there's 1 oxygen, which is 16.00 grams. If I add all of these up, I'm going to get approximately 46.08 grams of ethanol. So now I'm going to multiply 500 times 1 times 2 times 46.08 divided by 180.18 grams times 1 times 1, which gives me 255.744. Now I need to do sig figs. Conversion factors don't count. Conversion factors don't count. Conversion factors don't. There are 4. Decimal, significant digit. These zeros are significant, so I need to do 4. 1, 2, 3, 4. This is 255.7 grams of ethanol. In the next problem, we're calculating the volume of carbon dioxide, and we are starting with 10 grams of glucose. So we know we have to go to mole ratio because, again, element and compounds are different. So 10 grams of glucose, diagonal units have to be the same, grams of glucose. We know that there's 180 grams of glucose in 1 mole of glucose. If I stop here, we're at moles of glucose, so I need to continue on. Moles of glucose, diagonal units have to cancel out. We could go to moles of CO2 because we're at mole ratio, and that's the only time we could change elements and compound. Now we need to find the coefficients of CO2, which is 2, and the coefficient of glucose is 1. Diagonal units cancel out. We don't want to stop here because we're at moles of CO2. We want volume, so I'm going to go again. Moles of CO2. Moles of CO2, there's 1. Volume is 22.4 liters of CO2. All the units cancel out except for liters of CO2, so this is 10 times 1 times 2 times 22.4 divided by 180.18 times 1 times 1, which equals 24.864. Now I need to do sig figs, conversion factor. There are 3. These zeros are significant because there's a decimal and a significant digit in front. So my final answer has 3. 1, 2, 3. I look 1 to the right. 24.9 liters CO2. So pause the video and try the next two. Again, we are using the same balance equation from above. So I just recopied the balance equation from above. We are starting with what's given, which is 17.5 moles of ethanol. And we know ethanol is C2H5OH. And we're looking for the moles of glucose. So I need to go to mole ratio. Since it's moles of ethanol, my diagonals have to be moles of ethanol. And I'm going to moles of glucose because I'm at mole ratio right now. So the number in front of glucose is 1 coefficient. In ethanol, it's 2. So 17.5 times 2 divided by equals to 8.75 moles. There are 3 sig figs. This doesn't count because it's a conversion factor. So I have 3 in my answer of glucose. So in this next problem, we're going to start with what's given, which is 17.5 grams of ethanol. And we're looking for atoms of glucose. So we know we need to go to moles because we're going from ethanol to glucose. So diagonal units have to be the same, grams ethanol. We know this is molar mass because it's grams. So 1 mole of ethanol. We calculated that as 46.08 in the previous problem. The grams of ethanol cancel out. We don't want moles of ethanol, so we need to continue on. This is moles of ethanol. And we need to go to glucose. So we need to go to moles of glucose. From the balance equation, there's coefficient of glucose is 1, coefficient of ethanol is 2. This is moles of ethanol cancels out with moles of ethanol. If we stop here, we're at moles of glucose, but we don't want moles of glucose. We want the atoms of hydrogen that are in glucose. So I need to continue on. Moles of glucose. Moles of glucose. Since glucose, remember, is C6H12O6. When I have 1 mole of that, there are 12 moles of hydrogen. Because in 1 mole of glucose, there are 6 carbons, 12 hydrogens, and 6 oxygen. And remember, moles measure any amount. So I need to go again because I do not want moles. I want atoms. So moles of H, this is going to be moles of H. We're going to go to atoms of H. And when it's atoms, we know it's Avogadro. So 6 times 6.022 times 10 to the 23rd. So I'm going to multiply 17.5 times 1 times 1 times 12 times Avogadro's number. Divide by 46.08 times 2 times 1. And if you plug it in correctly, you get 1.3722 times 10 to the 24th. Now I need to do sig figs, conversion factor, conversion factor, conversion factor, conversion factor. There's 3. So 1, 2, 3. I look 1 to the right, less than 5, so the 7th stays. Times 10 to the 24th. Make sure you write your exponent. Atoms, hydrogen.